researcher, it will eventually break one day if it's not maintained by we're defining a community. So this problem actually also tricks AI. So you can see when you ask the version points like 9.9, whether it's larger than 9.11. In mathematics, it's actually 9.9 is larger than 9.11. But why, when you ask this question, the answer actually is going to the path of the versioning, is basically because of the training data itself. I think you have so many versions out there. And there are, for example, the AWS. For the AWS CLI, they publish a version of the AWS CLI Python packages every day. So this will be fed into as training data for the machine, for the AI, the large language model. In the end, it will answer your question actually in the wrong way. So this is still the problem, the problem I just mentioned doesn't have a solution. Is still a very challenging problem. Like even in the industry, there is no perfect solution yet for you. So if you have a Python package versions, so essentially, if you want to resolve the versions of different packages, is actually the graph search problem. So you from your version, your package, you want to install the package A, and the package A depends on B, C, D, and you depend on the package X depends on Y day. And at the end of the day, you're trying to figure out a version number can match them all to meet all of the constraints. This actually is a graph search problem. And this graph search problem actually, you can solve it in a very high computational ways, just comparing it. And this is how the poetry was doing, and most of the packaging was doing nowadays. But this is extensionally not a solution going forward, because what I have seen today nowadays is when trying to use a poetry, trying to do this resolving, it's probably take you 2 hours or 10 hours. You won't be able to find a match of the specific versions, like meet your requirements. So these critical edge cases potentially can be a research question if any of you are interested into the graph and the graph search area. But you need to know that this is still a problem. If you face a problem like when you're trying to plug install locally, resolve the conflict of the packages, you cannot solve that. It's not your fault. It's a whole community fault. And you don't really have to work around with that. You just need to either give up or find a tweak by yourself. So there are a lot of dependency management tools actually in this area. So first, we have two things to manage. One is Python version. Another is the dependency of the packages. So to manage the Python version, in the early days, we use PyEnv to manage the Python version. It's like the NVM in the loads. And then we use a virtual environment. This actually is a package developed by the third party over the days. So you can use this one to create a virtual environment with a newly installed Python version. And you probably wanted to get them involved into one tool, and you can do both. This is the idea comes up with a PyEnv, which combine the pipe and virtual environment creation, and it will create a pipe file, which will be similar later when you check the React concept. It will be similar to the package.json files. So when going forward for the AI and machine learning, we find out we not just want to maintain a Python package, we also want to maintain a binary package or dependency. How we do that, the current tools won't be able to do it easily. This is where the Conda was come out. So Conda can help you manage different Python versions. It can also help you manage different virtual environments. And if you want to install a package which is not actually a Python package, like the Torch, eventually the Torch actually is a binary file, so you're trying to download it and put it locally as like SDK, and then you use that. So Conda is actually pop up for this purpose. And recent several years, you have the Poetry. Poetry is, like when it's first being proposed, is designed to solve the problem I just mentioned for dependency conflict. is like a substitute to solve that problem. But their problem is solved it in a pretty they think the problem is so simple, but actually the problem is more from the human and not the software end. So even the poetry nowadays is have the best ways to manage all the dependency resolutions and find the workable solution. It still want to be able to solve the dependency core problem I mentioned earlier. So as we mentioned, we have 4 different solutions, and which one to choose? I think you have 2 ways to choose it. The first way is if you solve the scientific computation of this, then use a conda, which is our scenario, as us, when the purpose we are trying to build here. And if you're trying to build a normal Python package, just to do some a scientific calculation or just a normal tools to crawl a website online, you probably choose a poetry because it will solve the general concepts. They are better. So the decision point between these two is whether your Python package will require a lot of package developed by the research community. If yes, then use a conda. If not, you can use a poetry. And the solution for me, I was proposed here, I think it's very valuable, is the first one is when you use a conda, how you should do. So you use a conda to install a Python version, and then you use conda install to install different dependencies. But in this way, you need to care about your disk spaces. It's normal you will take a lot of disk spaces if you have a lot of conda environments. And another traditional way of doing is you use a brew to install different Python versions, and then use Python virtual environment built-in capability. This command here to install a virtual environment. This is another way. And then when you're trying to deliver your solution to the production, you use a Docker to Dockerize it, and then deliver it just as a Docker file and an entry point script. So in this way, you will be able to deliver your solutions just a Docker-based as a container, and it's up and running. And the last one is the one you can do, but I don't really recommend you do it here in this project, which is use poetry. But if you go into the industry and you are not working heavily in this research area, you can use a poetry. That's really the standard tools you are using. And the conda way how you do it, I give the code example here. So first is create it with a specific version, and then activate the virtual environment. Then install the packages, and then you can freeze the package while the pipe freeze. In this way, you can manage which version you actually install locally. But this way, it will export all the dependencies out. So when you're trying to install it in another computer, you probably will hit some problems. So the actual way I prefer is actually doing this manually. So here I actually install the request. I will create a requirements.txt file, and then put a request and check the version of the package I actually installed locally and put it in the requirement.txt file here. In this way, it's very good for the long pen and the torch, but it will hold a lot of disk spaces you need to check. But for us, we need to use this. And the traditional way is you install a Python version, you create a virtual environment, you activate it, and then you install it and do the similar ways to freeze a package version. And then the Docker way is something like this. You basically, from a base image of the Python, you already have a requirement txt file somewhere when you develop it. You copy it, you install it, and then you build it for a project and push this Docker image somewhere for the production usage. This is actually the poetry way. Poetry way, you need to install the poetry first with this command, and then you need to create a new project with this command, and then you need to add. This is different commands as we have seen earlier, like the pipe install. This is actually using the poetry add, and this will add the lumpies, and it will create the py toml file in your local. That will be your requirements file in this context to manage all of the specific versions of your packages. So the best practice is actually, I don't really have best practice, just the recommended ways for our AI engineer or Python projects, which is definitely create one virtual environment per project, and always check your requirement.txt, make sure it's up to date with your requirements. And inside your requirement.txt, you must say what's your version, because without the version, later you will have edge cases or conflicts. And document your setup process in the README, because in some edge scenarios, you probably need to first install a Linux dependency. For example, GeoPanda is a package we will use later for the geo data. For that GeoPandas package to be successfully used, you need a binary package in the Linux system called GDL. But you won't be able to reflect that in your requirement.txt. You need to put that in your README, so another guy who pour your repo down and trying to set it up locally, they will be able to know what you are trying to achieve. So this is about the virtual environment. Next is about the Python package project. So normally, what's a project folder structure will be like? It will be something like this. We have mentioned you need to have a Git. Use Git to mention it. So that's a Git. Then you must have a Git ignore. And for the Python project, you must ignore your virtual environment and your py cache file. This shouldn't be pushed to the cloud. And then you should have README and requirement.txt. This setup.py is required when trying to publish this package to the pipe. And then you will have a folder called your project name. For example, here we say it's AI4.a, and here you will have another folder called AI4.a. Inside it, you must have this initiated PI file. This file indicates this folder is a package to be used. If you created more nested folders inside of this one, every folder must have this file. This file will be empty, there is nothing inside it. But you must have this file, because this one will decide this folder is a package you can import it in the Python. This is something actually I want someone to tell me when I was like still a very junior people, but Python you need to have material this. And then under the same folder hierarchy level as your project, you should have a test file. It must be named starting with tests or test. And then inside it, you also need to have this initiator file. And all your test files, no matter which like a nested hierarchy directory you are in, you must have your file name start with test. Because the PyTest or other standard test environment or tools will use this like whether the file is starting with a test or not to determine whether this Python file is a test file they need to run. So you must do it something like this, but you can name it as test A or test B or test C. So this is the overall structure of your Python packages. When you go back to trying to process some data or write your own AI machine learning program, you should think about starting this. The good part of this is like you can reuse your code also. So if you want to log it, like put the logs for your file or for your Python scripts in utilize.py, you can put your logs there. Or if you want to call the API, like update some status, we will do later, like this. You want to update some API data in the cloud. But this API core, like a script, you will be used a lot of different places in your code. Then you probably need to have another file here called API.py. And inside it, you manage all of your scripts to call the API there. So this is basically the concept of how you manage your projects. And then here are other possibilities you can include it in your Python package structure. First is about documents. Documents is the one to generate the documents later for other people to understand what they're doing. It's same as the documentation you read for the Django or the Lumpy or the Panda. Scripts will be the places you store some useful script you were using locally. For example, you have your like AI or machine learning program up, and you have some like a script you will keep typing in your command. It's a very long one. You can actually create a script to store your bash script there, and next time you try to call it, you can just need to call that script you're writing. And examples is a good practice if you are publish like a package for the general public to use. So you can give some examples, other people can know how to use your package more efficiently. The data will be the places to store your like a project data, but depends on the size of the data or confidential data. You probably don't want this to be included and committed to the Git repo, or you wanted to do that. Depends on your purpose. And you have a notebook file folder. There is the places if you want specifically adjust or test your code. You can have a notebook folder. Inside there, you will have the code to like import all of the packages into this Jupyter notebook and trying to work around with different combinations of the experiment. But this one definitely won't be called in the production layer. It's just for your own experiment. You can commit it for the like a teamwork or something like that, but it won't be able to deliver as like a production package. The configuration file will be the places you probably put a configuration. Normally we will use the YAML to do the configuration if you have a very complex configuration setup, and that will be the case actually in current like machine learning programs. So what I'm doing actually is using the config.yaml, and for example, I need to configure my OpenAI's key, or I need to configure also my my AWS key or all the things. I actually put that in the configure.yaml and read it from there. And the configure.yaml, the production version of it, you definitely ignore it in the repo, but you should include example of that, because that's all the valuable credentials you should push to the cloud. So the best practice is basically similar as when we was teaching how to program in the first days, like isolation, modelize, comment. So you need to keep your related files together, separate your code from the data, and must have a clear import path. And you must have a very good naming convention with all your folders, file, and your classes name, variable names. Because in this way, your teammates can know how to work together with you to make sure your code doesn't have any confusion. So about the Git ignore, this is one of the examples of the Git ignore. These are typical things you shouldn't include in your repo. Two of them are actually the IDE related, some of them are the text related. What I normally do here is I ask ChatGPT to generate a Git ignore file for me for my project. For example, I say I want you to generate a Git ignore project for my Python project. And it will give you the code, you copy it here. And then you can read it through it to see what's your specific folder or file you want to ignore. You add it to this list in this file, and then you commit it, push to the cloud. In this way, you will get a very, because GPT will give you a best practice from the industry, and then you adjust based on your specific requirements. So in this way, you will have a pretty stable Git ignore file. Can try to avoid a low problem later. We actually have an example. This is a package we developed. We already published it as a Python package. So if you want to understand the practice side, how you do it, you actually can check this code there. So you can see this is a folder structure we have put, and we mentioned previously. And we have the Git ignore files. We also have the Python project TOML files. So if you when you're trying to go through these slides and you have some confusions, you go to this project and try to find the corresponding concepts and understand how it works. So about the development, the first thing I was trying to mention, so we already set up, currently we already set up your Python project. The next thing we want to do is we were trying to do the development. The first thing we were encountering is how can I execute my Python code? Normally people do is just the Python and give the a main.py file and you can run the code by yourself. But actually you can do it in a lot of different ways, especially when you have the Python packages. So first thing is you need to understand what this if name equals main means. This is also something I hope I was being taught when I was doing the Python, but nobody told me. And later I checked it out by myself. So this means you have your entry point as a main file, this folder itself, and then inside it, this one here will be run. But every runtime, you will only have one default name as a main. So why we mention this, it means like you can write a lot of if name equals main in a lot of like sub packages Python file, and then when you specifically want to run that file, for example here in the script you have something like this. If you wanted to run this script specifically like this command will be, this if condition will match it, and then your main function will record. But if you kind of import this main function to somewhere else, and you call the modules from somewhere else, and then you're trying to run it from somewhere else, this command won't be able to be called. So in this way, you can put your test scripts inside it. I will give you an example later. So this is the first way, like the most intuitive ways you should do to run your modules in the command line, which is have the -m here, and then your package .module.script. This is the .py script you will call. This is in the end of the day, everything is running this. And then if you're using the IDE, you actually can using the debug tools it provided. For example, here I can give an example. So for example here, if you open the spatial temporal py file, you click this one, it's actually should be able to run it here, but it has some errors. But this shortcut the IDE provided is actually running this command for you manually. So they do this like a command line type work for you. That's what it works. And then if you're trying to do the TDD way, which is called test-driven development, test-driven development means you write a test first, and then you write the code, then you run your test to make sure your code runs. So if it's test-driven ways, you work this way. You run this specific test script, and to see whether it's passed or not. And yeah, this is the example that I mentioned. Like if you have this one here, this is the if equals main like script that I mentioned. If you have this one here, you can either in the command line say Python -n and run it, or you can click this file and get it running. But if you're trying to call another four files in these four packages rather than these spatial temporal things, this script won't run it because this if else condition here. And then it's a module import strategy. If you have a very nested folder like this, so you realize like a package inside of this one, and you have a helper here. How should you import it? There are actually two ways. One is doing the relative import, another is do the absolute import. Relative import, you have two dots here, which means you go like the cd command. You go to the like a double parent folder and then run this command. But don't do it in this way. This way, like you can see, like when you're trying to read this one, the code is not readable. If the code is not readable, it means this coding habit is not good. You shouldn't do that. The more readable way is this absolute import way, which means you can use this command, this like read the code itself and figure out which folder and which file this script it is, and then find out the code itself. In this way, it's more specific, easier to maintain. So remember to import this way. And also, like this is the reason why we should use the absolute way. So recommendation is, like if you currently use the relative ways doing that, change your habits. Don't do it that way. Similar things happen when writing the Reactor package. Reactor also can do both ways to do the import. But remember, do it in the absolute ways. Import it from the root folder and then cascade it down. So your code will be more readable and maintainable. Then there is another problem similar to the dependency folder and everyone was talking about is called import circuit. Which means A actually want to import B, B also want to import A. You have some edge cases. You normally shouldn't have this scenario if you get all your component designing the problem. But if you being pushed to these edge cases boundaries, then we still have a solution for this, which is one is restructure your code, put the imported chunk of the code be imported by both of them in a third file, then import them from the third file. That's the most clean and straightforward way. And if you can solve it in this way, when you have the imported secret. If you cannot do that, then do it the second way, which means you don't have this from import declaration from the top. You will import it when you run this function. Then this way, some of the cases you can also solve the problem. But this is not a good practice. And the last one is actually the circumstance is like you work with edge cases and you find out this way cannot solve it because this function or this class haven't been initialized earlier. You can do an if-else dependency injection, which means you have a if-else things. And if this requirements is met, then you can do this import. We actually needed to do this in a very edge case I have handled before. It's like in the QGIS. If you want to get a QGIS instance running in your Python script, then you need to do this way because you need to wait the QGIS being up and running first. Later you can import it. But the second and the last one is something you need to know when you reach this circumstance and you don't know how to solve it. You can go to these two directions for the solution. But normally you don't need that. And if you really reach this situation, use the first way first to solve these problems. And then is use class, not functions. When we was being taught in the Python unit, we was being taught how to write the functions in the Python unit. So normally the code we deliver is normally other functions. But objective-oriented programming is there for a reason, is very stable for a reason. And Python can also do that. The reason is like you can use objective-oriented ways to write a much more complex and maintainable code. So if you're trying to develop a Python package, or even later in your day from today, you want to develop anything in the Python, and you haven't done it in the class way before, starting to practice in the class way. This is how the class, the difference is these two. These are trying to do the same purpose. You can see the function way is originally, if it's simple as this, function way is much simpler. But later, if you have more status you want to share in your class, then this way you won't be able to manage all the shared variables easily. But in the class way, you can do it very easy. And in the class way, you actually have two very powerful or specific decorators you can use. One is called a static mass, which means this actually is a function. It's not relevant to your class. You can call it without the self or initialization of this class, which will make it very useful later when you're trying to write some abstract functions belong to the same concepts. So you have a list of the static mass, but they all managed under the same classes. In this way, you can make your code more isolated and manageable. And the second way is called class mass, which means this is a way for you, help you to initiate your class. So for example, here, this is a date class we defined it. And you want to initialize it from the string, which if you write it in code, then it means everywhere you have a string, you need to write this command again by yourself. But if you have abstract is as a class mass, then every time you have this string and you want to initialize this class, you can just call this command like this here. So this one can get your code more clean and abstract it. Later, if you want to maintain this one, you have a new data stream coming and you want to get your code more compatible, you just need to add an if-else here, then your code can be adapted to it. So that's the second mass you can practice. And again, it's about the code style. If we write a Python code, we actually have a lot of freedom to write it just if you you meet all the requirements of the syntax. But if you want to get your code more maintainable, you also need to make sure your code was meeting conventions. For example, your import of different packages should be ordered in a specific way. So when another person was trying to import new packages, it will be added to a specific places by the rule. And the same as the line length. For example, if you're trying to deliver your Python packages with 80 line characters in a line or 120 characters in a line, why we do this restriction is because we want to get our code more maintainable. So, and the black is trying to forcing your code to be consistent. So these are the 3 commands you should use when you're doing the developing. You just need to use a pipe install these 3. And for the isort, you just need to isort and dot or specific files for it. And it will change your code, make sure all of the code will meet the requirements of the isort. Same thing as the other 2. So you can go back to practice that to make sure your code style is meeting the industry standard. These 3 are the industry standard tools we were using. And then there is a particular order you should use it. So first you use the isort and then black, and then flag it. Flag it, we're trying to figure out is there any missing things here. And these tools actually should be put in the CI/CD pipeline. So when some new developers come in, then they write some code, they push their branches to the cloud. This check process should be run in the pipeline to make sure their code meets the linked requirements. So the whole code, when they try to merge together, they actually have agreement with how we should write the code. So that's basically the industry standard how you do that automatically. And then is a logger. Normally when you're trying to do the debug, I think my personal bad habit is I trying to write a lot of print, but that's actually not a good way to do that. You should use a logger. Python provided the logger functionalities here, but I would recommend you to use these logger group packages because it's logger is itself the built-in one. You can do some configurations. For example, the color. If it's an arrow, it will give you the red color. So all of this functionality is similar to the IDE one. VS Code, you can play with it and get it to a certain level, but you need time to do that. This logger group package actually already done that for you. All you need to do is just from it, import it, and then you can use this logger to log all the information labels like alerts, all the warning one, all the error ones. So using it and keep this kind of logging codes in your code spaces. Later, when it's running in the production, it will generate a lot of these logs. These logs means later when you have a bug in the cloud, you can easily identify where the code is, which code it is, and what's variables there was coding this one. So it will help you save the time when you're trying to do the debugging. And then the CRI, when we're trying to use other people's tools, we can just pipe install it, and then you use the command line and trying to do something. It looks very cool, like you actually running the command line tools, like the C# or C unit. You write your system like a bash interrupters, but we actually also can deliver that in a Python. So to run the Python script, you actually have 2 ways. One is using the Python script ways. Another way is you can directly define your own specific command line commands and then run it. So the first way, if we run it, we definitely need to take the parameters in. So one way we take it, the most lazy ways to do that is using the Python's built-in package called system arguments, and then you can based on what's the position of this argument and interrupt it as different argument and use it later. So the example code is this one, and how to use it, the example is here, and these 2 will be shown up here. So the script will be argument 1, and the argument will be the argument 2. But in this way, you definitely see it's not that good, because sometimes you need to restrict you have a name for your arguments, right? So how you do that is you using this another package. This package is actually also building on top of the previous one we mentioned. The difference is this one can do this kind of parameter name, like a dispatch already for you. You don't need to write a long code to do the functionality, it's already built. So when you're trying to use it, you basically declare this in your code. And then you can see you declare arguments, and then what's the variable it will be stored to, what's like an action it will do, and what's like a haircut description it has. And later you can code it that way with 1, 2, 3. And the integers is the later things. The 1, 2, 3 will be taken out here. So in this way, you can give your command line coding with more like a descriptive names and the variables. So your code and your package will be more user-friendly. And then on top of that is you want to do it some way like this. You don't really want to write a Python here. You want to pretend you are the expert. Or specifically for your cases, you don't want to write a very long command line. Then you can use this click function, will give you decorators for your function, and you have the options. Later, when you're trying to run this function from the command line, you basically can do it in this way. You give it the variables and the names. It will be passed directly by this framework. So it's still the same. In the end of the day, still have as what we mentioned here. It will have some scripts somewhere written by the click to interrupt your parameters and pass the variables here, but they do it in the middle for you. In this way, you can create your command line tools. And then, if you wanted to make your packages into this way more executable, remember we said it earlier, you need to have a setup.py file, similar as, I think I have an example here. I can show you in the code base. So this is another package I was writing. So you can see I actually write a CLI file, and then in the setup.py, you just need to mention where is your CLI file and what's the function you want to call. When in the command line, you put the script naming, like what I put here is a client. So you don't really need to know how to do it very specifically. No, we are mentioning this, but you need to keep it in your mind so you can do this. So later when you're trying to do this, you can go back to search how to do it, or go back to my slices and understand how to do it and deliver it. So the summary is you have two ways to do the script command line running. The first way is you require the Python command. Another is you can do the professional distribution. It's just your defining the customized command. But both ways should work, and both ways can work for our projects. It doesn't matter here. And then is documentation. We read a lot of documentations. It's very important. Like when you do the interview, with the interviewers, especially if it's a technical interview, remember to mention to your interviewers that you care about this, because this definitely will distinguish yourself as a very junior developer, as an experienced one. The documentation is here for a purpose, which is the communication. You want to be able to every time get your senior developers or other groups developers come to you to explain their code for you. Only way you can do is you read their code and understand what they're trying to achieve. But that's not efficient. How you can do it efficiently is put your mind and write a documentation for it. So later, the other people can come to you, to the documentation, understand what we're trying to achieve there. So the codes can only tell you what it does. Documentation should tell you why you do it. So when you're trying to do the changes or do your applications, you can know why and make the correct decisions. So what's the modern approach? Modern approach is I know everyone trying to get our work to be minimized, so you don't really want to spend half your day to write the documentations by yourself, just to repeat what you have done in the code. So the industry standard is writing your code together with your documentations. So your documentation actually live together with your code in your comments, and then later we will use the tools automatically generate the documentations from the code itself. So you don't really do the maintenance by yourself. How it works is also this example we have built. So this is a package we have built, and you can feed from this website source, and here this description level of the documentations here, they actually build from the code. So you can see you have a specific format you put it in the code. All the description things you put it in the code in the markdown format or other format is just if it meets the specific format, it will automatically generate this one. And later with a minimalized setup, you can generate a website like this for your code to be shared with other people. So basically the whole process here, you don't really need to spend much time, but it will get your code more professional and easy to be shared with other people. So that's about the documentations. And what I mean, you should write it from the code. This is what I mean. So if you have a function here, you're trying to deliver this function, you should start with this kind of common things. This is called a lumping style. You should put your parameters here and give it what's the type of the parameters and what's the parameter was actually used for, and what you will return. Like here is that this is a float value, and what's a float value means. If you declare this way and then write your code forward, then in your code base later when you're trying to generate the parameters, you can see here it will become a parameter table. So you don't really need to define this table by yourself. The code script automatically generated for you. And you have other formats. Different people have different habits. You have other formats how you write this, like comments. This is the Google style you can do. And then later, how we achieve this status is you use a document generators. We are using this package to generate this kind of websites. You can use other tools, like there is py to doc or something like that. They are valid options. We just show you examples how we do it in this way, and it's definitely doable because we already done that, and it's pretty simple. And you can also fit into this document generation process into your CI/CD in your GitHub. So you can see in the GitHub process, you can install this file, and then you just run this command. It will push your generated documents to the GitHub pages. And this is where our document website actually is hosted. So you can see it from here. There is a GitHub provided packages. This is actually where our documents website was being hosted. And all you need to do is just do this CI/CD described here. You can get that done. And then the next important part is the testing. Remember to write the testing. This is the testing structure we have explained before. But why we write the testing? This actually is the basis. Nowadays we actually can use generative AI to do it for us very efficiently. The test cases itself is not trying to make sure the current code you are writing is correct or not. You should already test it very, very carefully to make sure your code you're writing now is meeting the requirements. But the test cases you put there is for the purposes later when someone was changing some code somewhere else in the code base. They don't want to break the earlier changes, which means they need to have some evidence to support what they have done is correct. Then, at that time point, when they run in all the test cases and make sure all the test cases is passed, where it means their changes haven't break what you want to achieve. This is just a quality assurance things will be very, very beneficial later. But when you're writing the test by yourself, when you're writing these functionalities, you will feel you are very stupid. That's what I'm feeling when I'm writing it. Because you're just doing things that you need to assert this return x equals 1 or 2. You think that it's very obvious, but I tell you why you need to write that. And this is the basis. You can use the GitHub Copilot to do it for you. You just need to write in the comments, say, in these test cases, what I want to achieve. It will generate the code for you and it will work. Then in this way, you can increase your code efficiency very, very, very well. So this is a code like a PyTest. PyTest for the Python packages is basically, I think nowadays the default framework, testing framework we use. This is the class you want to test on, and this is how you write your test cases. You just assert when you call this function, the value is equals to this. So it looks very funny and very stupid, but later it's very, very useful. This is the conventions you need to follow. What I mean is like you need to start your function name with a test dash. And then the PyTest will automatically discover it and then run the test report. The PyTest, why people using that is specifically for a reason. Just now we are trying to test these 3 cases. We need to write 3 lines of code. If the whole test cases become very complex, you have a lot of parameters. Then how should you do that without too complex code? Is you can declare parameters for your test cases. For example, here you actually in the left file x, y, and expected. It will be put here and run it. So you can make your test actually also have a parameter come in. So in this function, it's actually already runs 3 tests for you, not just 1. And then later, if you have more and more complex edge cases come in, you want to test on. You just need to add more variables here. You don't need to rewrite a chunk of code there. So this is one of the functionalities we mentioned. There is a lot of very advanced functionalities PyTest actually provided. For example, skit or feature things. But we just mentioned here, you don't really need to do it in your code now. But later, when you're trying to use it, for example, features, you need to ingest the test data, get your test data prepared, and then you starting to can run the test. How you get your test data prepared? The feature is one way you can looking for. The other one is test coverage. So after you finish your code testing, you should have a metric to evaluate whether your test is good or not. This means coverage. I think that's already been teaching in the software requirements and testing. So you have the tools for the coverage. It will, based on your test cases, automatically generate the coverage map to say which line of code already been covered, which line of the code haven't. So they will generate a report, say 90% of the code is being tested or not. Then you can know what's the extra test that you will need to be included in the code base. And there are 2 different strategies trying to calculate the coverage of the test. One is called the line of code coverage. Another is branch-based coverage. So I would recommend you to use the branch-based way because branch-based way will be more important. There is a lot of edge cases here. But eventually, in the end of the day, you can use this command to generate the HTML file. When you open it, it will tell you which line of code is actually being tested or not. So you can go back to update your test cases to make sure all of the code is covered. The end of it actually is 100% coverage, but you probably want to be able to achieve that. So 80% more will be ideal, and the most important branches must be tested. That's basically one of the best practice and principles you should follow. And also the test process, like the command here, they will be run in the CI/CD. That's currently the CI means continuous integration. And before you do the integration, you need to make sure your code meets the style everyone agreed on, and you need to make sure your test actually all passed and reach a standard everyone was agreed on. And then is the distribution. After you get your code done, or the Python was being development, how you distribute your data to somewhere, you actually have several different ways. So first is open source, like what we have done and all other packages have done. You publish to the pipe. If your machine learning algorithm or things are actually your IP, then you probably don't want to be open sourced. Then you can get it in a private package. You can push to the GitHub and you pub install from the GitHub repo, or you can have a private pipe and you kind of pub install from your private pipe. Similar idea from the Docker's private hub. Another way you can do is what we mentioned earlier. You can Dockerize and containerize your application and deliver it to somewhere, another local machine or production machine or AWS ECS container. They all valid options. So if you wanted to deliver it to the pipe file, then you need to have this setup.py. This is basically a declaration file to tell your the pipe store what's your package is, who should connect to, what's the package was aiming for, and what's the requirements it meet. So basically, we actually publish this package we built. So you can go to the pipe. You can actually see the mapping with the values of the things we put in the. This is actually a setup.py file. Actually, is a computer file. So you can see it from here, you can see the maintenance who it is. It's actually mentioned here, and you can see the descriptions and your license, what's the things you require, and your README file is also being included. For example, the long description actually in the code base I read it from my README file. So when you publish it, you will be able to see something like this in your blog. So that's how you do it with a pipe. And then when you're trying to push it, it also can be put into the CI/CD in the GitHub. This code base also being published in that GitHub repo. You can check it. Basically, the command is using this command line, doing the upload with the build process, build files you have done before. This will upload it to the pipe and it's done. It's eventually is shipping your file, the package file, from here to the pipe. And then it is like if you deliver it from your Git, then later if you want to install it, you should use a pipe install Git SSH. But this way is very tricky because in the later, as we said before, you need to set up your SSH keys in your GitHub. Make sure you have the proper permission to do the SSH clone. So this means when you're trying to install this, your local computer must already be set up the SSH keys authentication already. This is one way you can do. And in the requirements file, rather than put a request as package equals 2.3.0 version, you can put it in your requirements file as this package name will be looking for this Git address. This will give you a pipe. When you're doing the pipe minus R install minus R requirements, it will come to run this command automatically. Another way is you can put it in your own private pipe configurations. This is some way you can looking for later, or when you're back to China, you cannot access pipe. This is one way you can looking for to do the pipe installation or distribution. And if you want to do it in a service-based way, which is a containerized application, this is what you are doing. You have basically a base image and install all the things. And then install your package. This command line is install your own package. And then you give it an entry point, which means what's the command line you want to keep running. And then you can run it locally or push it to the cloud, run it somewhere. This is the way it's like a really production ready in the AWS or anywhere in the world of the cloud platform. And then after you get this done, the deploy options we actually have two. One is doing it serverless, which is do it in AWS Lambda Cloud Function or Azure Function. Or you can do it in a traditional hosting, which is in the Docker containers, Kubernetes, or a virtual environment have a Docker, or you have a dedicated server to doing that. I actually doing both ways. It will be easy if you already have a Docker file being containerized. So you don't need to worry about that later. If you want to deploy it and you have a problem, you can come to me, I can help you. And when you're trying to do the distribution, you need to check it. That's actually a review about what we just like put it in the front. You need to make sure you have the documentation, whether you have the installation, instruction, examples of the usage, API documents, deployment guide, and when you have a problem, how to do the troubleshooting. These should all be included in the, at least the README or the documentation itself. And make sure you already have the tests passed and you have checked your version compatibility. And also you have security concerns, whether you have some packages actually already have a security problem, you have to fix that. So make sure your package haven't introduced a security risk for other people's packaging. And another way, like nowadays, we definitely need to use the GPU. So another problem for the distribution is how can we distribute it via the GPU way. So basically, you can also using the Docker with the GPU. All you need to do is just install the NVIDIA GPU drivers and also install the toolkit, have the Docker installed. And there you can use different base image. For example, this is the NVIDIA's one. You can import it to use the from. And if you're using a PyTorch for your AI machine learning program, you can use a PyTorch. If it's a TensorFlow, you can use a TensorFlow base image. So example is shown up here. This is one where you can build your base image from the CUDA. You can specific the CUDA version, and then you can install all the requirements, and then you can test this one and have the GPU support. But the difference is from the normal containers is when you're trying to use the GPU on your Windows or Linux machine, inside of this Docker container, you need to have this dash GPUs command flag here. This will make sure your containers will be able to access your GPU locally. So you can try to go back to test these two commands. It definitely works. I tested that. And then is the license. I think nobody really care about. But the problem is license is about the open source. If you don't have the license, your code, if you publish it here, it's not that good enough. The core problem is about, let's talk about license first. So you basically have two types of license. One is allow you to do a lot of different things. The most free one is actually MIT. MIT basically means you use my code. You can do anything. And if you, for example, you hacked the US government, don't come back to me. I don't have any legal liability for this. You do anything you want. That's MIT. Apache means you can also do the same thing, but you cannot use my brand. For example, I just published, say I use a Kaya or the AI for WA. I want to be that to be my own brand. I don't want other people to use that. But you can use my code by yourself, it's fine. Then you can use Apache's one. There is a lot of packages actually in this standard. But there is another types of the licenses. They restrict you how you use that. For example, the GPL v3, if they put a license in the license file that says you cannot use it for the commercialize the usage, then you cannot. So they will still have the permission. They can charge you or sue you because you use it for the commercialized purpose. So before you use different packages, especially when you're trying to build a commercialized product, check their license first. There are some of the licenses definitely restrict your commercialized usage. If you get that involved in the earlier stages, then later, if you really want to commercialize it, you will have trouble. For example, there is a package called PYMU-PDF. This is a very popular one, used for the PDF processing in the rack. But this one actually restricts you. You cannot use it for the commercial purpose. So if you want to process the PDF and you have a big idea to deliver the commercial product, don't use it. Use other things. Even this one is more like a production grade. Or you just need to contact them and pay a very high license fee. You need to do your own justification, and you need to. But when you're trying to deliver your code as a Python package, you also need to consider these things. Whether you want it to be commercial use, or you just want it restricted by yourself. So you need to put it in your license. like what we put in our package. I think I included license is MIT or GNU license, which I still have the license similar to the one was being included by the NLP-TLP, because I use that package, so I need to follow their license. So nobody can actually using this package for the commercial usage. So I think that's most of the content I'm trying to deliver today, which is starting from the virtual environment and the Python package and the development. Actually, writing the Python code itself is the simplest part. And then how you deliver your code as a command line tool, how to write the documentations in your code, make sure that you don't need too much maintenance later, how to do the testing and distribution in the Docker also, and the license. Any questions for today? Nobody have questions online? If not have a question, then today's homework is actually about we have that AI for .NET Python package we set up last week. I think it's Tuesday, Thursday when we're trying to demonstration to the Git. Then use that as a Python package. Implement it in some way. Yeah, here. So get your project set up properly in this way. So you should have all these different files. Even if it's empty, get them created. And push this one, commit it, push to the cloud. And then you can decide whether you want to add these other folders in your package or not. Do your own justification in your cases. And then in your packages folder, write something here. For example, if you want to, so you should already have your project idea. Then if you're trying to do something for your project, then how you process the data, put it something here in your packages, and try to run your package in the Python command way, and try to using different parameters, practice the things we mentioned in these slides. That's that's basically today's homework. And I will try to give the demonstration next week when we're trying to build a for end-to-end demonstration. But you need to at least try to by yourself first and understand each component, how they combine together. So where is my homework? So that's today's homework. And if you want to get it extended, you can try the GitHub CI/CD options. If you lose some track and don't really know how to do it, you can go to this link and get the ideas from here, because this is basically being implemented with the standard way I was mentioning. You can check the code and understand all the concepts and implement it by yourself. So that's today's homework. Any questions? Any question on that? I think if not, we will wrap it up today. And tomorrow we will talk about the database. The slides also already being published online. If you want to check, you can have a look. Okay, then that's it for today. Thank you guys.